SpaceX has begun moving an updated version of Super Heavy booster to its launch facility in South Texas, where the rocket will most likely be tested with the rarely used stand known as the Can Crusher. Interesting events are starting in the space industry, and I hope, like us, you are more than excited to catch all the updates. Welcome back, space fans. I hope you're all doing well and more than excited to find the new space update. In this video, we are talking about the transportation of Booster 7 to High Bay for Raptor 2 engines installation. But before that, we welcome you all to our channel. Make sure to subscribe to our channel to never miss out on any of our updates. SpaceX announced on Wednesday, March 30th, that a temporary road closure indicative of transport operations will take place on March 31st. Super Heavy Booster 7, B7, had left the High Bay it was assembled in many times the day before, only to return at the conclusion of the day. More than likely, SpaceX chose to continue working on the booster inside the High Bay's shelter, while another team prepared Starbase's orbital launch site for B7's arrival. Simultaneously, repositioning Booster 7 freed up space for SpaceX to start stacking Booster 8, which started the same day. The Can Crusher, a giant mechanical equipment, has been the focus of work at the pad. The major aim of that structural test platform, which is made up of two huge steel structures, is to crush Starship test tanks and Super Heavy prototypes to some extent. A few days before Booster 7's first brief trip outside the High Bay, SpaceX moved the bottom half of the structural test stand to the orbital launch site. Unofficial aerial photos of Starbase a few days later indicated that SpaceX had upgraded the stand with 13 hydraulic rams, all but guaranteeing that it would be used to test SpaceX's new Super Heavy. B7 is the first booster to use Raptor V2 engines that have been updated, and there are 33 of them. 29 elderly Raptors might be accommodated in Booster 3 and 4. Because of the 14% increase in engine count, the thrust section had to be rebuilt, and the number of central gimballing Raptors was increased from 9 to 13. The Raptor V2's improvements, on the other hand, are significantly more significant. The Raptor V2's maximum thrust has been increased from around 185 tons to 230 plus tons, in addition to considerable design simplifications that should reduce manufacturing costs. Super Heavy B7 could theoretically create over 7,600 tons of thrust during liftoff if more engines were added, whereas Booster 4, which never fired a single one of its 29 Raptor V 1.5 engines, might have produced around 5,400 tons. That 40% increase in maximum thrust very certainly demanded a correspondingly stronger thrust section, requiring a slew of mostly unseen design adjustments. Those adjustments must be certified, and it appears that SpaceX used a full Super Heavy rocket that could one day fly to check their performance, rather than a less expensive disposable test tank. Simulating the thrust of at least 13 of Booster 7's engines will most likely be the first portion of that testing. Once Booster 7 arrives at the pad, the test stand's cap might be mounted on top of it, allowing SpaceX to mimic both the thrust of all 33 Raptors as well as the stress induced by acceleration during launch, re-entry, and landing. Finally, while Super Heavy is laden with liquid nitrogen, SpaceX has begun installing a special fixture and plumbing that will allow all of the structural testing to take place. SpaceX could conduct cryogenic proof tests with benign LN2 or LOX, and even wet dress rehearsals with combustible LOX and methane propellants. With the same arrangement, even the structural test stand is sturdy enough to hold several thousand tons booster. Booster 7 could then be modified with Raptor 2 engines and mounted on Starbase's orbital launch platform for static fire testing once it is fully proofed. Based on road closures, SpaceX at least wants the option to begin testing Booster 7 as early as Friday, April the 1st. the day after it arrives at the launch site. If test readiness slips further to the right, which is likely, additional opportunities are available on April the 4th and 5th. Along with this, there's a lot on the high bay. A new canopy and new factory facility are being constructed nearby to boost production capacities, while the old high bay is being modified. This includes removing the construction elevator from the high bay's northern side and maybe installing a proper elevator inside the structure. New markings indicating the property line were put behind the orbital launch tower and the launch site, presumably hinting at future expansions, as seen by the start of earthwork there. New walls are also being built along the fence line that runs along to Highway 4 at the launch site. The orbital launch tower's old GSE, ground support equipment, was removed and replaced with new plumbing. Meanwhile, Ship 20 has been relocated to suborbital pad B and will no longer be tested. After returning to the launch site, both the chopsticks and the quick disconnect arm were put through a series of movement tests. However, the QD's arm claw, which allows it to latch onto Starship during fueling, has yet to be reattached. Also, the road north of the facility is being paved to support transport and traffic related to both Falcon and Starship. Plans also show that a high bay facility will be included in future construction, and evidence suggests that this may be currently in progress soon. This will be critical to getting a Starship program up and running in Florida, as the vehicles will clearly need to be assembled there. These bays are projected to look a lot like the Texas new high bay. Let's not forget to mention the orbital launch tower. The third and fourth tower components of the orbital launch tower of KSC, which comprise a chopstick bumper stop and an elevator shaft, are currently under construction. The feet for the building of a fifth segment have already been installed, and the feet for segment 6 have also been spotted nearby, indicating that these two components are about to be built. The tower in Florida appears to be the same, or at least reasonably similar to the one in Texas, and plans have been made for the remaining pieces to be built. Unlike Starship, where each component was rolled out as it was completed, it appears that this time SpaceX is completing all 8 segments before assembling the orbital launch tower. The concrete base for the tower is beginning to rise at the historic launch pad 39A in preparation for the stacking of the tower parts. The foundation of the orbital launch mount are being completed, and the first step of concrete filling for the tower appears to be complete. So a lot is going on here. With this, we have reached the end of our video. I hope you enjoyed these updates as much as we enjoyed presenting them to you. Thank you so much for watching and all the support for our channel. I hope to see you again tomorrow.